So now I'm going to show you how to construct a perpendicular bisector of a line segment in GeoGebra. So the first thing you're going to do when you open up GeoGebra is construct a line segment. So you select the line segment tool. You will click once for your point A, and then wherever you want your B to be. I'm going to put mine there, but I've created my line segment. And then I want to create two circles, one with center A and one with center B. So I'm going to select my circle tool and select point A. And I want my circle to have a radius that's the same length of this line segment. So now I'm going to come select point B, and I have a circle with center A and a radius of line segment AB. Now I want to do the same thing on the other side. I'm going to create a circle with center B and a radius of line segment AB. So we see that these two circles are the same size now. I'm going to select my mouse tool so we can look at this. I'm just dragging it a little bit. So now I am going to create a point at the intersection of the two circles. So right here, and you hover over and make sure it's touching both circle C and circle D. And I have 2 points that are equidistant to my line AB. We know this because AC is a radius, so that's the same length as AB. AD is the radius of the circle, so it's the same length as AB. BD, that's the same length as AD, same with BC and BA. Then I'm going to come and create a line segment that connects point C and point D. And you see here that you've created a perpendicular bisector of segment AB. We can check to make sure that it's a bisector by doing a few things. First, I'm going to put a point right here in the intersection of my lines. And then I'm going to come use the measure tool down here. I want to measure the length of segment AE. So I see here that that is 2.2, I believe centimeters is what we're measuring in, so 2.2. I'm going to drag this over so we can see, and then I'm going to measure the segment EB and see that they will be the same length. So EB is also 2.2 centimeters. So we know that line segment CD bisects line segment AB. We can even see if we change the size of our figure that those lengths still stay the same length because we constructed a perpendicular bisector. So you can play around with it and see that they are still the same lengths no matter where you move it. The other thing we want to see for a perpendicular bisector is that this is a right angle. And so we can also measure angles. So it says select 3 points or 2 lines. So I want to measure this angle right here. So let's see. Oh, my length is in the way. But I selected those 2 lines. And it shows us that I have a right angle there of 90 degrees. So you can see that we have now constructed a perpendicular bisector.